So how are the processors and other devices interconnected? Well, the connectivity with each processor in a distributed system means that they can send messages and data through the electronic communication links, which means I'm using the internal wires to communicate with each other. It's desirable to have two independent paths between nodes to provide automatic alternate routing. This is redundancy. When you have these types of systems, you want to make sure that you have multiple paths to get to from one processor to another. Now, most people will never have to worry about this. The operating system handles this. In some cases, application design handles this, depending on how well the application is written. But where we do want to take a look at is, well, what about data? If we have a database and we split that database into two, let's say customers A through M and N through Z, what are we going to do there? How do we make sure that these two are in sync, and do they have to be in sync? What about if you took a copy of the database in New York and had an entire copy of your shopping cart, let's say the electronic transactions, in Dallas? Well, what would you do there? How do you make sure that the two are in sync? And that's a question that a lot of people need to ask. Because if you want to maintain redundancy, the most fundamental question of redundancy is, how do I make sure that my redundant backup or my online backup is as accurate as the primary? And so you get into the whole concept of replication for databases, and these things get expensive. They're very expensive to do. Most companies will opt for a hot server that's basically running with the database, and they will keep a cold backup. So in other words, they'll keep a backup of the database and then leave it to the side, and then if something goes wrong, they'll bring it back up. Users don't need to know where the data is, they just need to access it. And they don't care. The system is what's supposed to handle that. So with all of this, the synchronization is the biggest problem. And the more redundancy and the more replication you have, the more complex it is. You also have problems in terms of recovery. If you have a cold backup, you have this similar problem. Because one of the things companies fail to do is they'll make a backup of their system, say, every night, and they'll take these data tapes and push them off. And then they fail to actually test them out to make sure that they are recoverable. And that's one of the biggest flaws that a lot of companies make in disaster planning. So what are the rules and practices for distributed systems? System-wide rules mean that there's a discipline for the distributed system and that it's enforced at all times, which means we know that a single application can run on a single server, or only HR applications will run on a particular set of servers, if you will. These rules govern between the nodes, security, data accessibility, program file transfers, anything else we're going to control via some rules-based or roles-based security or procedures to ensure the interoperability is seamless between the two as well as secure. Since the 1990s, you have this concept of open systems, where you can use vendors, products from different vendors, and they provide standard interfaces. We get this notion from like the Java standard, where you have the portal standards, where you could create these different applications that provide the portlets. And what basically a portlet is, it's a mashup. A mashup is basically a screen that has different sections of the screen that get information from different systems and pull them together. This whole concept of an open system means that we can have a system such as Siebel as a CRM system or PeopleSoft as a financial system, and it allows us to interface with it through a third party, like a portal, in which I can see information that's relevant to me from PeopleSoft as well as Siebel at the same time. That's the whole concept between an open system. And this is made possible through things like an application programmer interface or web services. APIs have been used quite extensively in application design to allow us to interface with another application. So we can add records, pull records, retrieve records without necessarily using the actual system itself. Or I can leverage the processing of a particular system. On the web services side, I have the same thing, except the web services uses a specific standard to actually do this. It uses an XML standard, extensible markup language, which is web-based. It basically looks like HTML and is widely used for internet traffic. So when do you distribute? A couple of key things. And it's fairly simple. Are the operations interdependent? If they are interdependent, right, then their planning, development, resources, and operations have to be centralized. Because you can't take each individual piece and just send it off to have it processed and come back. If it's interdependent, you need the result of task A feeds into the input of task B. And so they're linear no matter what. If they're not interdependent, if they're independent, then it's a clear case that it can be distributed. Things like HR systems, things like financial systems can be independent. One is not necessarily reliant on the other. While they do rely on some data to come back and forth, the processing in A is not necessarily reliant on the processing of B. Are the businesses really homogeneous? Well, if they have a lot in common, for example, IT needs a fast food franchise, then processing may be distributed, but planning and hardware selection should be centralized. We can use this post office and weather information as an example. The information may not be homogeneous, but I could still use that. I could still distribute those items because they're used in a kind of homogeneous way. And does the corporate culture support decentralization? Now, this is probably the biggest one. Does the corporate culture say that, you know what, we can have a small data center here for HR, a small data center for finance, or for different subsidiaries? This actually holds more when you're talking about subsidiaries than anything else. Should each individual subsidiary have their own data center, or should we consolidate? It's really left up to the individual groups because most of this is a commodity anyway, so it really doesn't matter. When you get to applications, though, like an HR application, should a subsidiary have its own HR application? Or should it be commingled with the core application? And it's going to depend on the functions. Cost pressures usually are the key factor for this. So there are two guiding frameworks that you can consider to distribute. You can distribute among a geographic, culture, or work-oriented level, and you have 7 items here. And the other is technology-based, networks, processing applications, where I can have sections of Java applications, or let's say Oracle applications, and then on another side, pre-developed, home in-house developed applications or outsourced applications. Then you get into a number of other decisions like, should I outsource the data center or should I not outsource the data center? Who's going to handle the maintenance and so forth. And if you want to handle the maintenance, you can bring it in-house. If you don't want to handle the maintenance, then you can outsource it into the cloud and have someone else maintain it. And that might be an example of a distributed system. So we're going to close there. We'll see you for Module 5.2.